Speak in English, please.
Um, but you know, the latest slide we have to explain the mathematics. It's the latest slide. Taking so the first one is
No, you have to use it. English.
um okay. So let's go. Let me present my first, like recommendation cross domain paper, and see we have multi-modal, multi-domains. So instead of objective, you instead of you um, maximize objective function for only one domain, they have multi-domain, right? You have to then they present cross-domain recommendation and domain disentanglement is topology data. So let's look at the outline. We have four parts. First one, as usual, is second one, let's work. And then we look at their proposed method. Finally, we have insight about experiment and analyze this. The last one, we have a short discuss and anything like their work. So let's take a look at the first one, the first part, introduction. I will have we have recommendations, so I will explain shortly about the cross-domain recommendation. There are two types of cross-domain recommendation: the conventional cross-domain model, and the second one. We have to. Sorry, there are two types of cross-domain recommendations. The first one is single cross-domain recommendation, and secondly is a multi-domain cross-domain recommendation. For single one, you can understand like we have multimodality, but they try to explore the information, the mutual information, and combine their the mutual information between modality, and finally they output and vector and predict the output from that vector. But there exists the second one, like cross domain or multi domain, like I mean
Too small, cannot see. You can use your hand.
um this one for multi domain, like sorry, I forgot what I said. Okay, let's move to the next slide. I want to tell you shortly about their proposed cross-domain instead of like each right domain specific domain share, and from this one is a user embedding for movie domain. There are two domains from this category, like movie domain and music domain. They want to track the mutation information between the domain. So from the user embedding from movie domain, they extract domain specific and domain share. And similarly, from music domain, they extract domain share and domain specific. At the last, fully connected layer, they concat the domain specific and domain share to present, like the mutual information for movie and for music. Okay, start in the proposed cross-domain recommendation. Author want to add domain event into the conventional cross-domain modality and cross-domain comments. You cannot this one. There are only two domain information, domain specific and domain shared, but in their proposed method, there are three information they would like to be correct. Independent, specific, and shared. And that's the last one. That's the last layer they concat them together to represent the feature of movie and music.
Can you give explanation beyond example about what exactly is domain independent?
Yeah, well, let me move into the second part. We will have like briefly about what's different between independent, specific, and shared.
Okay.
So the challenges they mentioned in this paper is that the balance between like the relevance and diversified. Like you have the information in broad domain, but it have to variation enough to to present and representation. And the second one is like this one. The second challenge is how to decompose the information, the movie domain and music domain into three smaller domains. So there are two challenges, and the author would like to deal with the challenges. For the related work, in the second part, I'd like to shortly present what is a single target cross-domain combination and the dual target. For the second one is entangled representation learning, and the last one, the correlative data augmentation. So single target, like as I mentioned before, we have multi-modality. So we have multiple information from multi-modalities, right? They try for single target cross-domain recommendation. They try to like concat fusion the information and output only one objective. But for dual target cross-domain recommendation, they try to output more than one target, like this one. We have two domains, domain A and domain B. They try to learn the feature embedding output from the user and item feature. The user fully connected by, for example, to extract the feature embedding and user feature embedding and item feature embedding. And then they have two kind of multi-layer perceptual network. But the first one is the inner domain multi-layer perceptual network. See only the information from domain A. You can see the red line over here. And the second type of multi-layer perceptual network is the they use another information from other domain like domain B, and they have X is orthogonal transformation. They add them into the learned feature embedding from domain A, and then they got output from other multi-layer perceptual network. And then finally they got the estimated user rating. Similarly for domain B, and they got second estimate user rating. So instead of having only one target, they have two targets. If we want to, like we have multi-modality, so we have multi-domain, we have to maximize the objective function for multi-target, right?
History was the actions from in the last picture.
This one,
Yes. It's the only feature information.
first step, as a first step, I have take a look at this. What is an orthogonal transformation? What exactly is it? But they initially create the X and the S act to the multi-layer perceptor. And then when they compute the estimated user rating, is have to back propagation back to recompute X and adjust for. Yes, they just mentioned that.
So at the start of the training, where you just init X.
Yes. It's not from any, intuitively, we would like to create X from like singular value decomposition from domain, but they actually initially from like random, I guess. They have not mentioned it in their procedural code.
But why extend a transform?
I think because the strip is not like it's X is only fit for user, but XT is fit for the item. Because we have the magic, right? We have magic like the rating magic like R by n times n, right? So maybe we have to transpose it to fit with the item magic.
You mean this RB cross will like create the reference vector for the item, right? And RB within will create the reference vector for the user.
I think both of them share they share the information. Yes, because XT contribute their information to RB and X contribute information to RA.
Can you explain what is the arrows? That we have two colors here, the red ones and the green ones. And I don't know what exactly they are like presenting.
The red one is the for within domain, like you have user embedding from here and item embedding, right? Red one denote only within that domain, like you from domain A, right? We have red one from WUA and WIA, right, within, but it's not same in the second one. You can look at the green line, and it's combined from WUB and WID from the green line.
So you mean the end of the arrow in the red one, they can see each other, but we can from the A cannot see the information in the green one, right? Like the information amongst the red ones can be seen from RA, right? Because we can see the cross and the A with it, but we cannot see the RD with it from A, right?
Actually, this is the example. Is a dual target cross domain. It's not our main target. Was it very great? It's not the auto propose method. This is an example.
Like
They
share
are
information.
they are shared information.
And can see from this figure, the measure X is not dependent on the user or the item.
Yeah.
how tomorrow is X. I
I
mean,
think it's like the shared information.
yeah, but then they just concat the X with the user visual and item visual and fit that better to NLP as well.
So I guess your question is, how do you compute the rating A cross and B cross given the feature embeddings and the X? Anyway, so Dang, the idea of this dual target cross domain recommendation is that you need to first of all trying to fit the models are domain specific ratings, right? And at the same time, you also need to fit with the, like you have the rating of the user in this domain, but for the item in the other domains, right?
Yeah.
Okay, so the X is gonna be like a bridge
Yes.
between the two domains. So the question now is how exactly that the knowledge from domain A can be transferred to domain B and vice versa through the use of X.
Oh, actually, I did not read this paper. I
Okay.
use this as an example that
I
we
see.
have different between the single target and the dual target.
Okay.
Yeah. So let's move to the next slide. Interpolative data augmentation, like we have multiple multiple informations. So we have this one we will I will present in their framework. Okay. So there this is the denote the notion we need to like read before we explore their proposed method. And they have two domain A and domain B, and for domain A they have a set a set item we denote as EA. RA is represent for the interaction measure. So it's going from 0 to 1. And it has several m times NA. And because this method, they use graph at the to extract the embedded feature. So they use GA as the GA as the represent for graph function, and the input of graph is user embedding. User embedding is shared between the domain and vector item embedding as VA, and QA is the edge between the user and item. So similarly, we have CB and RB and BD. So let's take a look at their proposed method.
Could you come back to the previous slide so I can confirm a little bit? So GA means the graph between the set of user U and the set of item V and the edge of them with QA, right?
Yes.
So what the QA and the RA have any relationship with each other?
Sure. They actually similar, I guess. Yeah.
So the QA is the RA.
Yeah, but they put it in graph, so the author present it as QA. Yes, true.
So QA is the RA. So the graph is just like really saying that neither they have edge between the user and the item or not, right?
Yes. So you may question that is that a this could be later. So let's move to their framework. it actually is like a lot of, like other paper work. So the first one, they have graph convolution neural network and propagation. They have interpolative data augmentation. And what they mention in the title from here, they have user reference, disentanglement, and the information fusion, how they fusion information together. And finally, they put they get the output from graph convolution and the information fusion together. They put together, and they use that as the prediction for both domain A and domain B. So let's explore each part. Okay. The first one is a graph convolution neural network. They actually not use graph attention. They only use graph convolution neural network. So they have they build up ET graph for user and item, and their their mechanism is behind this formula. So if you're not familiar with graph neural network, so we have to I will briefly present what I use. I actually, as you mentioned before, is a interaction machine, and D is a normalized degree machine, and E actually is the first the input of the graph neural network at layer L minus one, and WL and BL is a learnable metric, learnable parametric. So it's like we have the connection. We understand. We know the connection between user and items, and then we exploit from their neighbor, and like fusion the information between neighbors to get the final one. That the output they get two embedding feature for item embedding in user. That's they are the output of GCN network. So interpolative data augmentation, they are mentioned before. It's a very very simple. They add because we have domain A and domain B, we have to mix it up. So because the authors mentioned that we could have a richer information by interpolative augmentation, by the EU lambda parameter combined together to get a mix up, and did not add E augmentation for user, and they only use the embedding information from GCN. Okay, so that's all about the interpolative data augmentation they mentioned in their work.
So lambda is learnable, right?
Yes. You mean lambda?
Hmm?
Let me check. No, it's not learnable. They set it from 0 to 1.
So it's the hyperparameter.
Yes, hyperparameter.
Right.
So they sample it right from the beta distribution.
And let's go to the next part. User reference is entanglement. Yeah, because the framework is quite big, so I write to the first line about the framework. And what this entanglement is that the user embedding, user embedding from mixup and user embedding from other domain. They like use a model like variation of encoder to compute mean and deviation. They stack several on a fully connected layer, and the architecture the also mentioned before, like they mentioned like variation of encoder to compute mean deviation for domain independent, domain specific. And there's only one difference between mixup. Mixup will output the domain string, but DCN from domain will output the domain independent. So what is different between domain independent and domain string? Like movie, we have a movie and music domain. We have two domains. Movie, they mentioned that domains have we have like the reason. They just say the reason together, but independent, they cannot share together. Like movie has frame. Movie has yes. Domains share like the category, and domain independent like the speed of camera, the like it all have in the domain, but it cannot share to other domain.
I still don't get it. But what's the difference between domain specific and domain independent?
Let me see it again. Okay. They mention like rhythm they have in both movie and music, right? But is it different in movie and music? So the reason is independent. It's quite good, I suppose.
I mean, to me, it just increase more parameters, right? Just increase more parameters of the deep learning model. You can always call it domain specific one, domain specific two, right? Why do you need to call it domain independent? It's I mean, technically it's just adding more parameters.
Yes, sure.
Right. And by that, right, you can increase the performance of the model because you have more parameters.
Right.
So I mean the justification to be whether any like I still don't really get why on earth we need both domain specific and then domain independent.
I think it depends on how they use the output of that model.
It's into different classifier, right?
No, they all
Yes,
being
they
fused, right?
all like concat the independent and share and independent together and put in the domain classifier.
Because it's already original from the like the green one, so why can't we just take it directly from the green one and put it into the domain classifier instead of like is enough before we make it again?
I think when they take into that to classify what domain like we may
Just
use
an idea.
In the classifier, try to separate the information between two.
domain specific.
They want to have mixed up information. They want to enhance the information. like if we put it directly into the linear or fully connected layer to the classifier, domain classifier, they cannot have a mutual origin on other information from other domain. Like if we have this one, they could domain B could have the information from a little bit from domain A, like that's a one to they mention augmentation. That's the augmentation.
We can have to look at the level for 2 minutes.
So my question is why the input for the domain classifier, why can't they use a domain specific? Yeah,
They
The
have two
input-
domain classifiers. And
yeah. So both of them, they only use a domain independent embeddings, right? The vectors, right? Domain independent and then domain share. They don't use a domain specific.
In fact,
The domain
the
specific is still in the second domain
Yes.
classifier in the bottom.
like the
Specific.
specific is
The
for
first one
the
use
develop-
the domain independent and share. The second classifier use domain specific and that's it. But why do we need domain classifier?
we use domain classifier for because we cannot ensure that we can extract the domain independent accurately, right? So they add another classifier to make sure to guide the extractor to extract the correct information from domain independent.
So that would be up to loss function, right?
Yes, true. It's correct.
And the
So
buffer-
there are three loss function and they combine together. The first one is for independent, share independent of the first domain classifier. The second one is domain specific, but free user embedding method. And the last one is a prediction.
like multi-objective in the model
One is
combined.
this one is a prediction for domain A, and this one is a prediction for domain B, and there are two objectives. There are two targets in this protocol method.
To target and represent by three loss function, right?
No, the first pre-loss function they combine together to compute the loss function for domain A, and similarly they have three loss function they combine together to compute the loss function for domain B.
And we will have total like 6 loss function.
Actually, not think they have only 4 because they share the first two loss function.
The first two loss function.
This is for domain classifier, two domain classifier. The difference is prediction loss function.
So we have for loss function, the first two is the two domain classifier,
Yes,
and the second two is from the prediction from each
Domain.
platform, right?
yes, each domain.
And this four function will combine together and create the backbone propagation until to the graph convolutional one.
Yes.
So what is the loss function of the two classifiers?
Domain classifier.
Yes.
For domain classifiers, they compute cross entropy loss
Because
function.
it just predict A or B.
Yes.
Yes, that's right. Just predict A or B. A classification.
Do they have any reason for adding the domain classification?
This is want to guide the embedding each structure or domain independent on the domain specialist.
So they just don't want them to be collapsed. Like each vector will have its own information about its domain. Um, still don't guess why they need both domain independent and domain specific.
Actually, we did have our hypothesis to improve. I think from my perspective, I think we could improve a lot of things in this framework. Because like rating, we have interaction magic, and the author used interaction magic, and the value range from 0 to 1, and we could we could use another graph type like graph attention or something like that to improve a lot of things. That's sure we can test our hypothesis.
And yeah, but I just don't understand what some part of this framework.
I could like summarize the main part of this framework. Like the most important one is in the middle, the domain share, the mix-up one. Like it's so the whole framework is just try to separate the information that could be shared and what could not be shared with the
Yes.
other domain. And the most thing important that they could be shared, the domain share information. If you see that will have like connection to both information fusion and domain classifier. So that's the important thing of this. All you try to do is just try to create the domain share information. The whole idea is the user embedding, you separate it into things that you could share and could not be shared with other, right? Because in the middle one, the domain share has the most connected points into most of the information fusion or classifier. Most of them lead to our loss function.
Yes. There's a mix-up in the main part.
But I can find like any like it like not really different from the dual target. Like
Some question.
yeah, the idea, the main point is not really like different, but I think the new technique of them is that the domain independent and domain specific, but I can find like how they can like what is the specifically the improvement of creating a new like doing independent part like that to the model. I can see the like effect of that part in the new framework. Like if they just like focus on the mix up, it's not like really different from the dual target you mentioned earlier. Okay.
Let me see.
If
Still try to create the domain
Richard.
share information.
Hmm.
The only difference that instead of domain specific, you got something new, so the domain independent.
Yeah.
And I still think that the name domain independent means that the information is don't really rely on the domain. It's just like personal information.
No, it's like-
Because the name is maybe a little bit confused. It's
yes,
just
that's right.
independent,
Sure.
so-
The name is confused because they have one part here, but it's a little bit short actually.
If this is domain independent, then why we need two of them?
That's because the name is domain independent, so that doesn't make us very confused.
If it
Domain is mean like they would like to extract the information only in this domain.
Because it independent domains.
Let me take a look at it again.
It's making a little bit confused with it.
Yes, what? As the first time I read it, I have a same question at George. Like, why do they need a three domain, like independent sharing?
Ah,
They
oh.
basically
So they say that like you have a example like category, right?
yes.
Category is domain share, but another example is the rhythm. The rhythm exists in movie, music, and books, but in each domain they have like different meaning. So I think that will be the reason why they name it the independent. Like in the high level they have same idea, but specifically in the lower level they are have more detail and they are really different.
Yes.
Like rhythm in a movie and rhythm in music.
So in
Actually.
your example in C, right?
Yeah.
It's not.
So category is share,
Sure. Yeah.
rhythm is specific.
It should be independent.
Rhythm is
It's shared, but it's different in different domain, right?
No, I think
The reason
then it should be domain dependent, right? Why do you call it independent? But
That's the reason why we are confused with this model.
really like confusing.
where is it published, by the way?
um
And
Actually,
one of the thing that I
actually it's Brexit is gonna happen take place on September this year.
okay,
Brexit.
you should put the venue of the paper and the list of authors in the first line.
Okay.
So here the reason will be the independent and the frame will be specific, the same as the melody.
Share is category.
Share
Independent.
is rhythm.
Yeah. Independent reason.
Frame will be domain specific.
Specific. Yes.
Yeah. Okay. That makes sense for me.
But actually, we from my point of view, I would I have same idea as Dr. Zhu, like we add more parameter and then we have
So the simple way to see is whether they compare with the model where they have more parameter for the domain specific.
they didn't compare the number of parameter in this paper. They only compare the performance. Well, they didn't compare the number of parameters.
I have a question. As I say, it's a discussion about the front. As is in the domain specific in the middle layers about in
Middle.
which one? Yes. I think it's a abundant feature or abundant vectors in this framework. First of all, it does not contribute to the prediction on information into the two information fusion blocks.
Yes, actually, because it's by the back corporation.
The secondary reason I think is a only contribute to the second domain classifier, which is in the bottom. And I think the role of that vector in this block is separate the domain specific vector between the domain A and domain B. But I don't think it's important to add the first vector in this classifier. As in the second domain classifier, we have three kind of inputs. Is a domain specific from A, mix-up and B.
Yeah.
Yes, and I think this second domain prompt is only try to classify which domains the input factor belong to. And that's why I think that we only need the domain specific factors come from domain B and A is enough. And we don't need the domain specific factor produced from the mix-up.
Yeah, I think that's a great idea.
I think it's important to understand how they train the domain classifier. Each time, are they use each of the domain independent domain and domain independent as one input?
Okay, let me see. Long question first.
No, I think the idea of that they said in the paper that the domain classifier is to decouple the domain specific and domain independent user preference from user embeddings, not the class A or B. In the paper from 3.2 section, 3.2 section, the user preference is disentanglement. They say that propose a disentanglement model guided by a domain classifier to decouple more accurate domain specific and domain independent. Like they try to separate the domain
Yes,
independent and
they-
the specific.
And before they try to, like guide to the feature, try to
Like separate that to two features,
yes.
not
But the fine is they use cross entropy classifier. They use classification between A and B to guide the feature each one.
but I think if they feed the domain specific from the mix-up, because you said that the mix-up will be like the shared information, they should not contain the domain specific, but because the domain specific is different, right? Why they put them in the mix-up? I don't get it. What domain specific of the mix-up here meaning? The meaning of the domain specific of the mix-up. The name is domain specific, right?
Yes,
They should
like
not be related.
like movie, we have frame and
Yeah, they should not be related to each other.
yes.
Why they put it in the mix-up? And if they exist in the mix-up, what do
Intuitive
it mean?
behind that.
I can see the meaning of the domain specific. That's why
That's why
that they
yes, that's why long
right.
question about.
Yeah.
That's why long have.
Yeah,
checked
that's
on here.
yeah. That's why he
Yeah.
said the yeah. I can see.
And I mentioned before, like long is that's what it is.
Yeah. I just want to like make more clear of the
We
question.
should we could try to like omit the domain specific from the mix-up.
Yes.
Let's see what happened because they in the first class in the first objective function they had two term cross entropy function. You can note this one at section 3.5.
The loss.
Yes, the first loss function. This is why they did actually the specific house specific domain specific contribute to the domain classifier.
LCLS
One,
1.
yes.
The domain classification of loss function.
stop reading almost almost up.
Do you have any more slides? How about the experiments?
Yeah, sure. For the information fusion, as I mentioned before, they stack a lot of technique into their framework actually. For their information fusion, they mention they use several techniques to fuse the information together, and they mention the concatenation as requires attention mechanism. We familiar with it, right? For the model prediction, as we mentioned it before, we have for loss function, and then we compile together. For the first, for the two first is a domain classifier. The third one is the prediction for domain A, and the fourth one is a prediction for domain B, right? And for data set in the last section, experiments, they mention three tasks in actually two big data set, the Amazon and the domain. So we can see the statistic, but I think it's just smaller. The last one is around 200,000 item and to almost 1 million item and 200,000 users. So this one is smaller. They have comparison between their approach with the baseline. So the baseline from by DCN or single target domain they have mentioned, or in they mentioned it in the comparison, and then they put them together to get the comparison. So as usual, their approach is better than the baseline and the previous state of the art. They have three kind of the information fusion, right? So they have like three kind. They have several kind of domain classifier. But the first one we mentioned domain classifier as entropy, right? And then they train the clock entropy as an algorithm in the papers we mentioned that, and they have that version for their proposed method. Yeah, they show their improvements again. The best baseline. They improve almost 10%. Yeah, 10% for the domain movie, and for the Amazon they also achieve significant improvement. Yeah, I think it's quite obviously.
Best for this hit rate is 15%, right?
Increase
For the first data set.
first data set, domain movie.
The next one is hit rate about 15.09% in percent CDR, right? So I 10.04%.
So they don't have any comparison in terms of
Parameter
number of parameters.
Yes.
So what is the difference between the fixed version, base version, and Apple version? In their framework?
The improvement. What is the difference?
You mean difference between their proposed and baseline?
Yes, they said that here's the best baseline.
The best baselines and they use baseline from this one. Their baseline.
So, again, the
This one.
the best umbrella here is the, like, the number with underline, right?
The second. is-
Yeah, the one with the underlying score,
So where is the
numbers.
1.4% come from?
Okay, I guess I use a 16.66 minus
You
15.09
can count
and
it.
then divided by
You
15.09.
can count it. Yes, I think it's almost 10%. Just
Yeah, I mean,
because
this
I'm-
one is just to say I am how many times better than the best baseline. But I think the missing experiment should be like, what happens if I give the let's say the descent CDR and then I give more parameters for the domain specific representations at the same level as, same number of parameter as the data CDR here.
Yeah. They
And
should compare the
I,
number.
I want to see the performance with that model with the same number of parameters.
Yeah, sure. But they didn't be that.
Yeah, I mean, this is a typical deep learning paper where you just add more parameters, right?
Let me take a look one more time. But sure, it's not in this paper.
Okay, anything else?
They the performance between
Okay.
yeah, I mentioned before, information fusion. They have several information fusion techniques, so they have different performance.
Okay.
And yeah, that's all about this paper. Thank you for listening, and this is the first presentation of our weekly reading activity. So
Uh, I think we cannot record that. Where did you record?
Yes, I have record on Teams, so I guess everyone can download it and watch it again.
When did you record? Since which
Right,
part?
right. Yeah, I record right before, right when the meeting starts, so we have a full video of this presentation.
Okay. So you still have your video. Okay. One question down. I thought the theme is large language models.
oh, sorry, because you sent it the list, right? And in the list, I picked the last one.
Oh, you picked the one
Yes.
has nothing to do with large language model.
It's confused. I mean, what title should I place? So
Okay, no worries. I mean, reading group is reading group. You can present anything that you like. But we give everyone the theme so that across the week we maybe revisit something relevant to the common theme, and then after a while people can pick up something from each other's. Right? No problem.
Actually, I thought this paper is belong to like last week with more topic, but when actually I read this paper 2 days before.
You raise your hand, right? You have any question?
No, I just talk. I have to left because Ray invited me in another meeting. So next meeting I cannot join.
Okay.
Yeah,
Okay.
yeah.
Thanks for joining. Yeah. Okay. Any follow-up questions for Dang?
I think we could like I mentioned we could improve it a lot because it's our like a technique. It's nothing new.
Okay.
It would be if we introduce or interest in we could improve it.
Okay. Yeah, so I guess we are kind of late, like over time for this reading group. So who gonna present next week?
I gonna run page, run page.
Okay.
Yeah, you know, like.
Any any
run in
volunteer?
web, and then I go to that website.
We should.
Now, you want.
One more thing, anh Dũng, I suggest we should have a Slack channel or a Facebook group where everyone can discuss each other about
Yeah,
the paper
I
afterward.
already done to it,
Yes.
so that organize that. That's right.